Welcome to This Explainer. Today, we're diving into something that is quite literally redefining the AI landscape, exploring the sheer, unprecedented scale of the newly released Kimi K3 model. If you've been following the rapid evolution of large language models, you already know that the gap between open-weight models and those top-tier proprietary giants has been a huge point of debate. Well, we are unpacking a technical report today that actively closes that gap. To really wrap our heads around Kimi K3, we got to start with a massive number, 2.8 trillion. That is the total parameter count here. It instantly establishes K3 as a true titan, pushing the absolute limits of open-weight intelligence. For a long time, the open ecosystem was kind of hovering around the 1 trillion parameter mark, risking stagnation while the proprietary models just kept pulling ahead. But Kimi K3 shatters that ceiling entirely, scaling up foundational pre-training to a whole new paradigm. So here's our roadmap for today. We'll briefly meet Kimi K3, talk about rethinking the architecture, dive into training for deep reasoning, check out building the infrastructure, and finally look at the future of OpenAI. All right, Section 1, meet Kimi K3. Let's get a high-level overview of what makes this model so groundbreaking right out of the gate. What's really fascinating right off the bat is their native multimodal vision encoder, known as MoonVit V2. You know how a lot of models just sort of graft a vision encoder onto a pre-trained language model through a really clunky post-hoc alignment stage? Well, Kimi K3 doesn't do that. It natively processes visual information like images and video frames right alongside text in a massive 1 million token context window. Because it was trained entirely from scratch with next token prediction, the language and vision representations are completely unified from day one. You could literally drop a massive code base, a technical manual, and a bunch of complex diagrams into the prompt, and it processes the whole shebang holistically. Moving right along to Section 2, rethinking the architecture. Let's see how K3 goes about solving the massive bottlenecks that usually come with this kind of scale. Think of this architecture as the model's central nervous system, where information flows in 3 distinct dimensions. First, for sequence length, they use Kimi Delta Attention, or KDA. This replaces the infinitely growing memory caches of traditional models with a fixed recurrent state, which is basically the secret sauce for managing that million-token context so efficiently. Second, for network depth, they rely on attention residuals. Instead of just blindly passing data from one layer to the next, each layer can selectively look back and pull specific representations from all preceding layers. And third, for model width, they use stable latent MOE to dramatically expand the network's capacity without completely exploding the computational cost. Let's zoom in on how it manages that width, because it's super clever. Think of the mixture of experts architecture like a massive consulting firm with 896 highly specialized experts. When a new piece of information, a token, comes in, the model doesn't ask all 896 consultants for their opinion. That would be computationally impossible, right? Instead, it activates exactly 16 specific experts who are perfectly suited for that exact token. This keeps the math incredibly lean while retaining the vast knowledge of a 2.8 trillion parameter brain. And the tangible results of this architecture? Compared to its predecessor, Kimi K2, the leap is just staggering. Total parameters jump by 167%. The actively thinking parameters per token, the activated parameters actually doing the work, increased by 220%, up to 104.2 billion. And the context length explodes by 8 times, going from 128,000 to a full 1 million tokens. By refining these architectural foundations, Kimi K3 achieves a massive 2.5 times improvement in overall scaling efficiency compared to K2. All right, Section 3, training for deep reasoning. Having a giant brain is one thing, but how do you actually teach it to execute complex reasoning over long horizons? During reinforcement learning, K3 is put through a really rigorous autonomous execution loop. They place the model in highly complex, million-token environments, things like full software engineering workspaces or professional financial analysis tasks. And the model learns to independently navigate these by following a continuous loop. It reasons about a problem, acts by using a tool or writing some code, observes the results of that action, verifies it against strict constraints, and then adapts its approach if it made a mistake. It does this over hundreds or even thousands of steps, actively learning how to solve problems that take a long time to figure out. Now, obviously, teaching a model to do all of that perfectly all at once is incredibly difficult. So instead of trying to build one generic model out of the gate, the team trained specialized expert policies across 3 distinct domains: general tasks, general agents, and coding agents. They even train these experts at different reasoning effort levels: low, high, and max effort.
Then, using a technique called multi-teacher on-policy distillation, they took all these separate, brilliant specialized teachers and distilled their knowledge back into a single, unified powerhouse. It's basically like downloading the coding skills of a software engineer and the deep research skills of a data analyst straight into one entity. Which brings us to Section 4, building the infrastructure. Because standard GPU clusters would literally melt trying to handle a 2.8 trillion parameter model without some entirely new engineering paradigms. At this ridiculous scale, memory walls and imbalanced GPU loads become multi-million-dollar headaches. Think about it. If one GPU is processing a highly utilized expert, while another GPU is handling a rarely used one, that second GPU just sits idle, wasting time and money. Enter Kimi's Moon EMEP system. Moon EMEP guarantees perfectly balanced expert execution. It dynamically plans redundant experts so that token loads are perfectly distributed across the hardware. No single GPU is overworked, and no GPU is sitting idle. It maintains absolute peak efficiency across the entire cluster. And then there's the context parallelism approach, another major infrastructure win, especially for managing that million token context window. In traditional softmax attention, GPUs have to constantly talk to each other and exchange key value memory blocks. The longer the document, the bigger those memory blocks get, until the network just chokes. But Kimi Delta Attention uses a new approach. Instead of growing infinitely, it exchanges a highly efficient fixed-size recurrent state. No matter how long the context gets, the size of the data being passed between the GPUs stays exactly the same, which massively reduces communication overhead. And that leads us to our final stop, Section 5, the future of OpenAI. When you combine this revolutionary architecture, the rigorous reasoning loops, and this masterclass in hardware infrastructure, where does K3 actually stand on the global leaderboard? Looking impartially at this benchmark data from the report, specifically for complex software engineering and coding tasks, the results are honestly phenomenal. Kimi K3 posts a 67.5 on DeepSuite and a 90.4 on the Kimi Codebench. It consistently outperforms other major models like Opus 4.8. In fact, it's trailing only the absolute top-tier closed-door proprietary systems GPT 5.6 Sol and Fable 5. It is holding its own at the very bleeding edge of artificial intelligence, proving once and for all that open-weight models can absolutely compete in the heavyweight division of deep reasoning. As models like Kimi K3 hit this staggering 2.8 trillion parameter scale, they're pushing open-weight AI to heights we used to think were strictly reserved for locked-down corporate labs. It reshapes the entire landscape, proving that with the right architectural flow, training, and infrastructure, the community can access frontier-level intelligence. And honestly, it leaves us with one incredibly exciting question to ponder. What happens to the global tech ecosystem when the open frontier inevitably surpasses the proprietary one? Thanks for joining me on this explainer. I hope this helped unpack the sheer technical genius behind Kimi K3. I'll see you next time.